Hello, I am now doing the exam review part 2. Let me go ahead and share my screen. Okay, perfect. Let's see here. Okay, getting started here. So, question 1, identify the population and the sample.
Okay, so you have a keyword here. Of 1,503 US adults, found that out of those 1,503 US adults, 78% favor government policies requiring better fuel efficiency for vehicles. So let's take a look at the options. The population is 1,503 US adults. No, it's not. Population includes everybody. Population is the collection of responses of US adults, and sample is this sub-collection, which is 1,503. This is a correct answer. Number 3 says population is US adults who favor government policies, and sample is 78%. It's not correct. This 78% is the result of that survey. In that survey of 1,503 adults, 78% favor government policies. And finally, the last one says population is all people live in the United States, and sample is 1,503 US vehicles. It's not. Let's take a look at the next question.
Okay, so for question number 1, population is the collection of the responses of all US adults. So that is telling us what the population is, which is the all keyword US adults. And the sample is the collection of the responses of the 1,503 US adults that were sampled. Okay, moving on to the second question here. Determine whether the numerical value is a parameter or a statistic and explain your reasoning. In 2012, Major League Baseball teams spent a total of that very long number on players' salary.
503 US vehicles. It's not. Let's take a look at the next question. In the next question, we have determined whether the numerical value is a parameter which is related to population or is a statistic which is related to sample. Which one is related to that? So in 2012, Major League Baseball teams spent a total of about $3 trillion on players' salaries. So a total of, right? So this is a keyword for you, everyone. First of all, when you're looking at the multiple choice, the very first one says the statistic is the total amount spent on salaries by all teams. Well, it's not statistic. Statistic is about sample. It's not about the population. So this is not correct. The parameter, this is based on a survey. When we see the survey is all about sample, not about population. Statistic, it's an estimate of the total. Again, we have total, so total is always about population. And then parameter is the value of about $3 trillion in numerical description of the total player's salary. This is the correct answer. So you need to identify the keywords here. Statistic, subsection, survey, and parameter is about total, everybody, everything.
Okay, so the answer is going to be parameter. Keyword there is total. The parameter is the total of the description of the salary for the players. Oops, let me hit next. Okay. Question 3, determine whether the data are qualitative or quantitative. Let's see. The zip codes of a sample of 200 customers at a sporting goods store. All right.
Words here: statistic, subsection, survey, and determine if you have a qualitative data like categorical data like hair color, blood type, and so on. And quantitative data are the data that when you do algebra on them, the algebra makes sense. So if you find the average of grades, that makes sense, am I right? But if you find the average of social security numbers, it doesn't make sense. Here you have zip codes, the zip codes of a sample of 200 customers at a sporting goods store. So since you have zip codes, if you do algebra on zip codes, if you find the average of zip codes, that average doesn't mean anything. So it means that you have a qualitative or categorical data here.
Okay. Oops. Again,
Qualitative
hold on.
or categorical data here.
Okay, so this is qualitative because zip codes are labels. They are not, they don't have like a numerical measurement because they are zip codes. And question number 4, determine whether the study is an observational study or an experiment. Researchers conduct a study to determine whether a drug used to treat hypothyroidism works better when taken in the morning or when taken at bedtime. To perform the study, 90 patients are given one pill to take in the morning and one pill to take in the evening. After 3 months, patients are instructed to switch the pills. Let's go ahead and check out the video review.
Next question. So in this question, you have a data set that represents the number of minutes a sample of 25 people exercise each week. So you have 108 minutes, 115 minutes, 101.
Oh, I think that is not that correct.
Minutes, 180. The class width. What in your code to?
That is not with that one.
Which is the class. The midpoint of the first class is the summation of these two frequency, basically 8%, and subpoint of the first class is frequency, the cumulative.
Sorry, I'm just trying to
The
find
left or
that.
right
I think that
frequency,
one's not
basically
there,
constructing
which
a
that is
so
okay.
that's the number of minutes in good
Let me
store.
pause it
So
again
it
here.
mean anything. So the set that represents.
And we can just go back and talk about this one. Okay, so researchers conduct a study to just determine whether a drug used. So for this one, I'm going to go with let's see, observational. The researchers only observe when patients take the pills without any intervention. Excuse me. 90 patients are given one pill to take in the morning and one pill to take in the evening. After 3 months, they are asked to switch the pills. So I am going to say that this is experimental because the study is applying a treatment, which is the pill that the patients are taking. Okay, now we are on to this one here, which was the next video.
It's the number of minutes a sample of 25 people exercise each week. So you have 108 minutes, 115 minutes, 101 minutes, 118 minutes, and so on. So in constructing a frequency distribution for the data set using 5 classes, you're going to identify different things. So first of all, let us form the class width. What is the class width? Class width, as you remember, is the range of the data divided by the number of classes. So you have 157, which is the maximum value in your collection, minus 101, which is the minimum value in your collection, and divided by 5 because you have 5 classes. When you do the division, the number is 1102. But when you're constructing a class width, you always round up to 12. So here you have your 12.
So for the first part, the class width, midpoint, relative frequency, data. Oh, that's actually not a question, so we will move on.
Let's build our frequency table. The class starts from 101 and stops at 112 minutes. The next class starts at 113 minutes and stops at 124 minutes and so on. And note that the difference between these two is 12, which is the class width. Okay, and as usual, we count all of the values in between these two numbers inclusive. The midpoint of the first class is the summation of these two numbers divided by 2. The midpoint of the second class is the summation of these two numbers divided by 2, and so on. We can also find the class boundaries and the frequency for each class and the relative frequency, basically dividing the frequency of that class by the total values, which is 25. So 3 divided by 25 is 12%. 11 divided by 25 is 44%. 7 divided by 25 is 28%, and so on. So now the question says the midpoint of the first class is, well, the midpoint of the first class is 106.
Okay, so the midpoint of the first class is listed here, 106.5. So the midpoint of the first class is 106.5. Okay, and then the relative frequency of the second class. So the relative frequency looks like it's 0.44, but let's see.
0.5. Guys, do not round these things. Midpoint is representative of the first, second, third, or other classes. We don't round them. So the midpoint of the first class is 106.5. In the next question, after building and constructing our frequency table, again, remember, we need to find the class width first, which is 12, and then we build our classes. We count the number of values in each class, the relative frequency, the cumulative frequency, and so on. Here the question says, what is the relative frequency of the second class? The relative frequency of the second class is 11 divided by 25, which is 44%.
Okay, so like I said, the relative frequency of the second class is 11 divided by 25, equaling 44%. 44, oop, fix that, 44%. And the data seems to be, let's see.
So you're gonna write it as, let's move on to the next question. When you graph the data using your frequency table, this is the visualization of the data. As you can see, if you want to be fair, we have the data and the graph skewed to the right-hand side.
So the data is skewed to the right. And that's because looking at this, the tail is on the right-hand side.
This is not a normal distribution. So if the question says the data seem to be skewed to the left or right, we're going to say that it is skewed to the right-hand side. The tail of the data is on the right-hand side. So
like I said,
we say that the data is skewed to the right side. In the next question, we want to find the quartiles, right? So let us list the data from smallest to largest and then divide them up using the midpoint, which is the middle value, the second quartile, or the median. So the median of the data is 123. 123 divide the data into two halves. The first portion on the left-hand side and the second portion is on the right-hand side. After finding the median of the data on the left-hand side and the median of the data on the right-hand side, we basically have all the information that we need. So the minimum value is 101. The first quartile is the mean of these two data. This is the average. 117 plus 118 divided by 2 gives you 170.
Okay, so we were looking for the first quartile, and on the graph here, it's going to show it's the midpoint of all of this data here, and it is 117. It is between 117 and 118, which is 117.5. All right, so moving on to question number 6, we have um weekly, excuse me, weekly salaries in dollars for a sample of registered nurses are listed, and there all of that is. And then we're going to find the mean, median, and mode.
17.5. And as we know, the median of the data is second
I think I'm
quartile,
gonna
one
have to
third, the
open the
third quartile.
next
And the max, what is the first quartile?
YouTube video. Yes, I am. Oops, which is gonna be here.
Now let's take a look at next question. Here you have the weekly salary in dollars for several registered nurses below. 949, 621, 1,194, and so on. Question says find the following: mean, median, mode, and it says round all to one decimal, for example, 23.8. So that's how you round them to one decimal place. Then the question says which best describes a typical salary? Is it mean, is it median, or is it mode? And the question says find the following range, variance, and standard deviation. And it says round them to the closest whole number or integer in this case. So let's use our calculator. Let's jump into calculator. I'm using calculate 84 to do the computations here. So first of all, I go to stat, and in edit, I'm going to enter all of these numbers in L1. So the very first number is 949, enter, 621.
Okay, so all of those numbers are being entered in L1.
2, enter. The next one is 1135. We're going to go to stat. And then go to calc. So here, select calc, and it should be on one variable statistic. Everything is in L1, so we're good to go. This line should stay empty. Hit enter. And let me move this here so we can see what do we have. We have X bar, which is the mean, 926.625, but says round to one decimal, so you're going to have 926.6. Then here the median is 959.5, and as you can 96. So then
let me
here the median onto one decimal, so you're going
so 926
to have 926.6. Then
926.6 is the mean. Oops. So we're going to enter 926.6. And then the median we can see is 959.5.
Here the median is 959.5. And as you can see, the mean and median, well, they're very close by, am I right? That's not a huge difference between them. So it seems like the data is not skewed to the left or skewed to the right. So both mean and median are good representative for the data. But since the data is not skewed, we just stick to the mean itself. Do we have any repetition here? We don't have.
So 959.5, 959.5. And let's see the mode.
Have any repetition here, so it means that the mode doesn't exist.
Mode does not exist because there's no repetition. So we're going to write DNE.
Now let us take a look at our range of the data. Range of the data is the maximum salary, which is 1135 minus the minimum salary, which is 619. Just do the difference between them. And for the standard deviation, this is a sample. So for the standard deviation of the sample, you're going to use S sub X integer, or variance, you're going to take your variance. So let's take a look at the step-by-step solution. So let's take a look at our step-by-step solution for those of you who want to do the algebra. So X bar, as you saw, is about 926.6. The median is 959.5 after rearranging data from smallest to largest. Well, the average of the middle numbers is going to be your median. The mode doesn't exist, DNE, or it's none. And let's take a look at the range. Range is the maximum value minus the minimum value, which is 575.
Oops.
And here I showed you the table, how to basically build everything from scratch to find the variance. And
so the range is max, minimum, max minus minimum, which are these two numbers, 1194 minus 619 equals 575. Oops. That goes here. 575. And the variance.
the standard deviation. And then finally, the calculator, calculate 84, that has all of these functions built into it. So on the exam, I don't expect you to write down the table like this. You need to write everything using your calculator, making calculations much more easier for you. So as you can see here, you have S sub X, which is basically your sample standard deviation, which is 219. And here you have 219, but remember that the question says, hey, round to the integer, closest integer. So you have to skip all of those decimals. It's just going to be 219. And then
219 for the standard deviation. We're getting rid of those decimals.
And for the variance, you're going to take your standard deviation and raise it to the second power, which is this number here, 48, 135, and then just to skip this
48, 135, 48,135. And then the question, the typical salary is best described, I would say, by the median. Because it's just like in the middle of like all the salaries, so it's less affected by like outliers. So that would best describe the typical salary. And there that is. Oh, I guess we're gonna submit.